Okay, guys. Announcements. Warm-up and exit tickets. Remember, you miss school. That's your responsibility. I've been talking about them. They're on here. But still, I'm missing a bunch. Now, you have to come in during your time. Now's not a good time to be passing those in. Morning, when I have time. Lunch, when I have time. Okay, not the class's time, but it's more your time and my time. I take them then. So you need to be responsible about that. I've been showing up here early to make sure you guys have an opportunity to do that. Doors open at 7:30. I'm here. Come on down. Videos that I post. You guys that have missed a lot of school for basketball, I think you guys have been gone 3 times in the past 2 weeks, right? You got to go online, check out the video. It has on there the warm-up exit ticket. Check out the slides. Do that first. That is a way to stay connected. So if you're sick, Jayla, or you miss school, that's another way to stay connected and not fall behind. Eli. Yeah? Yep. The unit review is due tomorrow. It's online. I posted this on Google Classroom as well. So this is your way to prepare. This is due tomorrow. We're going to do a little bit different activity than we did last time with the unit review, but something similar. Make sure you have it. Make sure that you know how you got your answers, because that's kind of like part of the activity. And then test on Thursday. I'll have the Kahoot up there. You will need to put the Kahoot on it runs through an app. It doesn't run through a computer, through a desktop. Okay? So you just get the Kahoot app. It's free. Okay, you put that on, and then you can do the challenge. I will say that I think that the Kahoot app will allow you to be more prepared for the open response questions. Because I do have on there, not the whole open response questions, but like a piece of it, so you can see how challenging it will be. Ratios to help determine if figures are similar. What's a ratio? Talk to your partner. So Peyton, what's a ratio?
A ratio is a comparison of numbers, kind of like a fraction.
Okay, it's a comparison of numbers using what though? Division. Very important that it's using division. So, and then we know what similar figures are. And so we're going to be using that again today to kind of look at another way to figure out similar figures. On your warm-up, you had to copy down these 4 figures, 4 rectangles. And it asks you to use length to width ratios to find similar figures. So, there are 2 pairs of similar rectangles, and your job was to find those pairs. There's at least 2 pairs. There's actually 3 pairs. So, how would I do a length to width ratio?
You would do one length and one width.
Okay, so I have to figure out what's length and what's width. So if this here, if I consider that length, what's length on this one?
9.
Eli?
The 9 inches.
No.
The 15.
The 15 inches. Because we are now considering that to be the long side, so then I have to rotate this so it looks similar. What about B? What would be the length in B? 10. And what would be considered the length in D? 20. Make sure you code yours like I'm coding mine. So if I'm coding that with 1 dash, my width would be 2. That helps me when I go do the work, that I don't get confused and put the wrong value in whether it's the numerator or denominator. I can keep it consistent. So in A, if I'm using a length to width ratio, what would be my ratio?
I don't know if it's one, if it's 1, 2, 3, and 2. Like, those types.
So what would be the ratio I use for A? Because Peyton already said a ratio is a comparison of two numbers by division.
20 divided by 12.
20 over 12. Okay, and what's the ratio for C?
No.
Justin. Good. Making sure that we're keeping consistent, right? And Cam? B?
Okay, 10 over 6.
10 over 6. And D, Connor? So, I have the ratios, but what do I have to do to those ratios to see if they're similar? Yes?
Convert them?
Not convert them.
Make it proper?
Reduce them. So, I'm going to reduce 20 by 4. 4 goes into 20 5 times. 4 goes into 12 3 times. I have a ratio of 5/3. So what does that mean? Yeah.
For every 5, 12.
Not exactly. Not bad though. Let's say I convert this to a decimal now. So 3 goes into 5 one time. Does that help you now, Connor? No? Does it help anybody if I converted that to 1 and 2/3? Callie? Yeah. What does it mean? What does that 1 and 2/3 now mean?
Well, to me it means that it's for every one, like there's 2/3 of a, or for every one width there's 2/3. Okay, sorry.
You're getting close.
Yeah, for every one width there's 2/3 of a length.
So it's basically this. For every 1 and 2/3 width, that equals 1 length. Does that make sense? Because I have a length to width. So if I have a 1 and 2/3, it means it takes 1 and 2/3 of those to make one of those. Okay? So if I have 1 and 2/3 width, I'm going to equal 1 length. Yeah.
If it was just a fraction of the 3 of the width,
Not exactly, because you're forgetting what that fraction means. It means that if I took 3 of them and I broke them into 5 pieces, that's what. Each piece has 5 pieces. That's what that means. But let's go to this one. Let's not get hung up on that. What I want you to understand is that the width, it takes 1 and 2/3 of those to make one of those. That's what that ratio is showing me. So here I can reduce by 3, and I get 5/3. Here I can reduce by 2, and I get 5/3. Here I can reduce by 2, and I get 10/3. So based on those ratios of length to width, which of those figures are similar? Talk to your partner. So this is what I get. Because this is the big idea from this lesson. If you get this, you're on the right track. A is similar to B, B is similar to C, and A is similar to C. That's pretty easy because they all come down to, so which one of those is an imposter? Yeah?
No, I'm not responding.
Dylan, which one's the imposter? D. So I want you to label that. We have an imposter. It does look like it might fit into that family, but it's not. So this is, what do you notice about similar rectangles in the ratio? So if these ratios are all similar, that's what we're saying. These shapes are all similar. What do they have in common? Otis?
They all equal 5/3.
So what does that mean, though?
Their ratio is
Their ratio is 5/3. Yup. Go deeper. What does it mean? Ashton, do you think you know?
They both have corresponding angles and sides.
Okay. Look. They're all rectangles. So what did it tell you about angles? It's all the same. But they do have corresponding sides. Only A, B, and C have corresponding sides to each other. So what does that mean? Take that a little bit deeper. If they have corresponding sides, they have something. Look at the poster. So, if they have
they're the same shape.
If they have corresponding sides, what does that mean? They all have a scale factor that goes between them. That means if I wanted to, I could find the scale factor from A to B, A to C, and C to B, and the other way. So if they have ratios that are the same, and the ratios all follow the length to width, then they have a scale factor. And that means that they're similar figures. That's the idea behind the ratios, is that I can use them to find similar figures. That's our target for today. Okay, we talked a little bit about it yesterday. Any questions about this? Does that make sense?
Yes.
That what Ashton said about having corresponding sides is exactly right. But then take it deeper to know that in order to have corresponding sides, you must have a scale factor. That is a really important power idea, power standard. Any other questions at all about that? Okay, put that away. And go ahead and get 4.1, 4.2 in front of you.
4.1 and 4.2.
Oh, come on. Why? Please. There it goes. All right. Here. All right. So, going back to this idea of using ratios to discover if objects are similar. Because then if I can use a ratio really quickly, simplify, I then can say, oh, these two are similar, so there's a scale factor that goes between them. It goes one way, and then the other way is the... No, it's not the opposite. What do you call it? It's the reciprocal. So if one weighs 2, the other weighs a half. If one weighs 8, the other weighs 1/8. So that is kind of like a shortcut to finding scale factor quickly. Is just looking at the ratio that you have between length and width. And it works with triangles. It works with rectangles. Okay? Any kind of figure where you have like a length to width ratio. So here, just like yesterday, we have objects C and D. We have a length, and I want you to code yours like I'm coding mine, like we did earlier. If I say length is the width here, that means the longer side over here must be the length, even if it's rotated differently. Okay? It's just oriented a certain way, so what you do is you orient it the same way. And then if that is the length, then this is the width. Make sure you're coding it, Cam, like I'm coding mine. So now I have C and D, I have a length of 8. In D I have a length of 4. The width is 2. and the width in D is 1. My length to width is 8 over 2, and here it's 4 over 1. This equals 4, and that equals 4. What I want you to understand is that this ratio only means this. It takes 4 widths to make 1 length. That's what that means. So this 4 means 4 widths make 1 length. And that same ratio happens here. Make sure you get this down, Brayden. The scale factor is different. And there are a few connections between scale factor and length to width ratios. We're going to list them down here. But what's the scale factor from D to C, and what's the scale factor C to D? Talk to your partner. So I wrote this down. I have scale factor from D to C is 2. And I know this because it's getting bigger, so it has to be bigger than 1. Because it's growing. And I look and it goes from 4 to 8. That's easy, like Dylan said, it doubles. So it's a scale factor 2. The other way is the reciprocal. And I just wrote here C to D, so I know that that means it's going the other way of 1/2. And I'd like you to make sure you have that too.
Can we also write that in one below it?
Mm-hmm. You could write in the one below it. But make sure you label it C to D, because up here I have D to C. So what does a scale factor and a ratio have in common? Oh, yes. That was perfect, Tatiana. What else? Both use division, right?
Both use corresponding sides.
Nice. Ooh, hold on. It's not necessarily corresponding, right? They both use sides. I almost, sorry guys. Both use side lengths. Because corresponding means opposite figures. Do they have a scale? Do both of them have a scale factor? Yeah. One is showing you a scale factor from a width to a length, and the other one's showing you a scale factor from one object to another object. Big ideas. Okay? Make sure, try to remember those. Real quickly, triangles are great with these ratios, but you always don't need ratios to figure out if a triangle is similar. Does anyone know why? What do you think you could use to figure out if a triangle is similar? Yeah? Angles. What do we know about triangles and angles, Justin?
All the angles add up.
So, I'm just going to put triangles, okay, if I have, and I'm just going to call it angle 1 plus angle 2 plus angle 3 equal 180. If they give me angles like I have up in here, I don't need to use any ratios. I just figure out if the angles are the same. And if they are the same, take a guess what? They're similar figures. And because they're similar figures, what do they share? Corresponding sides. And because they have corresponding sides, what else do they have? A scale factor. So sometimes you're going to have to orient them, right? And move them. And you're going to have to figure out the puzzle of like, what is the missing angle? So here, I have missing angle. Here I have missing angle. All of these are only missing one. So it's pretty easy to figure out what that angle is. How do I do that, Austin? How do I figure out what the angle is if they give me two angles in a triangle?
We just talked about this in this class.
Yeah, so what do I do?
Okay, so...
Like, how do I find out what question mark is?
Hold on. Don't you have to, like... Hold on. It's like right there. Can you come back to me?
Eliza.
You add up two angles in this practice.
So I got to add up these two. Whatever that equals, I subtract from 180, and then that is what that angle is.
Yeah.
Okay. So today, we're going to tackle 4.1. You guys have 30 minutes. 4.1 is going to start where it's not going to the next page.
Okay.
What is going on?
You're going to be in timeout when I get to 0.
Here you go. I got to wait for the thing to pop up. I don't know what's going on my computer. 4.1 starts on 83, guys. First do 81, and then it's just B1, B2, C1. Do not do C2. I don't want you to do that. Once you're done with that, and we will review B2. I'm going to go over B2. And we'll talk about C1. Then you go to 4.2 and 85. It's the same concept around ratios and angles, but they're triangles on 4.2.
Is that R2, B2?
And then you got A all, B1, B2, C all, and D all.
R2, B2.
Put that away.
R2.
Questions?
9.
Okay.
So we 83.
We're almost done with this second book. We're pretty smart.
Oh, 83.
Okay, I want you guys to discuss. Read the questions out loud.
Why?
Eliza, you know, because you guys are so good at what you do.
Oh, we're fantastic about it.
Okay? Read the questions and discuss and do your work together.
Okay. Well, which of the parallelograms are similar? I think it's F and G because the 52 degrees and 52 degrees and the angles are the same. Similar figures.
Which parallelograms are similar?
Okay. For each parallelogram, find the ratio of the length of a long side to the length of the short side. How do the ratios compare? So are we doing the ratios on the same side length parallelogram? I mean, are we doing are we finding the ratio of this number, or letter F and G and E?
For all of them.
Okay.
I think.
And we would do 3. We would do 10, 8. Right. Do so.
Yeah, totally. Yeah. And you remember, you don't need to convert them to a decimal. If you do convert them to a whole number decimal, that just gives you the representation of, oh yeah, the bottom one goes into the top one that many times. Does that make sense? Like if I say this, if I have, what is it, 7.8 and what?
7.8, 7.5.
So 7.5 over 6 equals 1 and
So much. Okay.
1 and 1/4. That means whatever this number represents as for a width, right? That it takes 1 and 1/4 of those to make one of those. That's what that number means. It takes 1 and 1/4 of those to make that. All right?
What's new? What does it mean by how does it compare? What? What does it mean by how does it compare? We have to start on 8. We do the page 83 first. Okay. Well, how they compare would be I don't know how they would compare.
Okay, yeah, great. So 5/4. So that means it takes 5/4 of the widths to make one
Oh yeah, I guess.
length, right? Basically 1 and 1/4. 1 and 1/4 widths make one
Figured those ones out.
length. That's what that number means.
Am I?
That's good.
So like,
So are these all, are they similar to each other? Are they different from each other?
we found that F and G are similar because this angle is the same and this one's different.
Okay, but maybe that one's oriented slightly different.
That makes sense, I guess.
Okay, that's good that F and G is similar. So this equals 1 and 1/4. 1 and 1/4. What is 2/4 and 3 equal?
2/4 and 3.
Yeah, 2/4 divided by 3.
It would be like 1.16. Wait, no.
See what you get.
Oh, you reduced them. So is it just like asking for the answers for each of these?
Hold on.
You're going up to 2.
So how many times is 24 going to 60?
24.
24.
1 and...
So what do you notice for all of these here?
2.16, I think.
2 point.
24. 25 going to 60. 24 going
6 goes into 7.5 2 times? That one.
Why are you doing it reduced?
Reduce this though.
No,
This
we
is
have no
2
idea.
eighths. What does that equal?
Okay.
1, 4. Right? 2 goes into, so that would be, what's 3/12 equal?
So when you do this, you just like slam that right there, right?
That also equals.
Or no?
Yes. Okay. I think.
Figure out that one.
Wait, what? No, then you would bring a
So,
0
yep.
down.
So these are all the ratios. Now, from this, can you tell if they're similar or different?
This one would be short.
Yeah, you can. You must do the division. Hold on. So, I'm seeing most of you guys you're getting the ratio portion right. You've got this down. Okay, then you have that. And I forget what the other one was. So, how do I know if these are similar? What do I have to do? I have to divide. I actually have to set this up like this and do the division. Or reduce it. So 8 goes into 10 how many times?
1.
With how many left over?
2 eighths.
That reduces to what? 1 and
2 fourths.
1/4. How many times is 6 going there? 1 with how many left over?
0.5. 1 and 1.5.
Can I reduce this?
No.
1.5. Does it go 1.5 going to 6?
Yes.
Yes. How many times?
4.
4. I can reduce it that way or I can do it this way. But just by looking at them, I can't tell if those are similar. I have to do the math till either it gets in its most reduced form or I can straight up divide. And you have to do it with the last one as well. Okay? You guys need to do the last one. You still don't know if these are all similar.
Yeah. Still.
What do you mean?
I want you to talk about it. Talk about B1. Just what I did.
So we have to actually divide.
Focus.
B1, what I put was F and G are similar because they have all of the same angles. He just said that if they have the same angles, they're all going to be equal. That's what I wrote for B1.
Yeah. How many times is 4.8? So,
And that's what
do
I'm
you know how many times 4.8 goes into 6?
Camera's only on you. Huh?
How many times does 4.8 go into 6?
Oh, yeah.
One time, right?
Get
How much
ready.
is left over? That's right now, because I know it goes in one time.
You're
6 minus. How much do I add?
Here's a mess. I'm on YouTube.
Cameron,
You
here's a
want
real
it?
mess.
Not one now. One and what?
No. Somehow, don't do it at me, because I don't want it.
Cam?
Smitty, you're supposed to be talking.
Minus 2?
Oh yeah, talking. Yeah, I'm talking. Right? I'm talking, right? Yep, I'm talking.
So that means 4.8 goes into 6 one time.
Are we supposed to go
With
over it or something?
Over? 1, that's not a half. 1.2
So be more.
over 4.8.
But just
I just
So
did
now,
this.
do you know if you can reduce that?
Did you
How
explain?
many times does 1.2 go into 4.8?
yeah, I explained. Because they
What
have
would
the
I
same
multiply
angles.
1.2 by to get
Hey,
this?
that's what I
explained.
said.
Said because I have the because. I'll underline it for you.
Did you get F and G?
4.
Oh, yeah, you
So that means
Yeah,
it goes in
F and G.
one.
It is.
So that's 1 and 1/4. That's 1 and 1/4. That's 1 and 1/4. What does it tell you
You're
about
supposed to
all-
be
about
talking.
F
Not
and
just
G?
going to your little.
They're all similar. They all have a scale factor.
There you go. Now you're not the only one in the camera. Angles. What'd you get for A?
For A?
Yeah,
I got
this
A
one,
and
they all have scale factor.
Because they
They all
have
have
corresponding angles.
Oh, you're wrong.
That is what.
Oh, you're real wrong.
Because you tell me something
It's
about that.
A, C, and D.
Look.
Because they all have the same angles. Look, this is
30.
They all
this
have
is
scale-
89.
similar,
This
they
is
have
69.
scale
That's
factor,
30. That's
corresponding
30.
size.
That's 89. That's
You know that.
61.
From.
That's 89.
Sure,
Oh, so
That's
they all
A,
have
C, and
corresponding
D.
Yeah. Yeah. Gee, I just gave the
Yeah.
answers again. It's the third time this week.
So now
Hey,
we
I
know
got
about
A and
that.
D right. Seriously? The third time this
They're all similar. So they all have corresponding sizes. There's a scale factor. You just know it, but there is. And they all have the same amount of angles.
So Smitty.
Cam,
I'm done with
go to
A.
the back. I don't want you turning around anymore. That's not working out for you. You're more interested in Schmitty than you are in your work.
I turned around once.
Well, I am interested.
Well, more than once.
Sorry.
If it was once, you'd still be there.
B1. That's all there is. B1 and B2. There's no B3.
Do you know what that reduces?
B1.
Because 1 point.
Why didn't I
What
just
do
say
do?
B all?
Multiply 1.2
I know, right? I don't know why.
by 4.8.
Because there was
If I
only.
multiply this by 4, I get that. So this actually turns into 1.
the ratio of the shortest side to the longest side. Shortest to the middle side. Okay.
Then he's trying to find the
Shortest side to longest
ratio,
side.
shortest side to longest side.
What do you feel like, right?
Yes, me too.
Shortest to
One
longest.
mistake. This actually
longest
reduces
to
to
20,
1
20
and
and 4.
12.
So 20 over 4.
They are all not equivalent.
Wait, shortest to
They're all
longest.
similar.
So 4 over 20.
And
No,
because
20
they're
over
similar,
4.
what do we know?
I don't know.
Shortest to longest.
All angles are the same.
So it'd be 4 over 20.
20 over 4.
No,
What?
I disagree with you.
sides are the same.
Or no, angles are
They always
the same.
do.
Yeah, they have corresponding sides. And because they have
Because you get
corresponding
almost
sides, what else do
everything
they have?
wrong.
Find the ratio of shortest side to
Those three
longest side.
I did 20 over 4.
Kayla?
Or 4. 20 over 4. 4 of 24. Shortest to middle.
How do they compare? You actually, yeah, you gotta do those divisions. You gotta do the
What's the
division.
middle?
And tell me if they're equal. Well, you already know.
I don't
You
know.
already know this one equals.
I'm gonna have to do me some
That one
math.
equals 1/4. And what did we say about G? It also equals 1/4.
Ooh, I want to see what happens if I do this.
Yes. All are similar.
Stay
Which
here.
means they all have that equal. They have corresponding sides and they have scale factor.
Dang it, it worked. Darn.
4 over 20. Okay, middle.
So what's the smallest? 4.
No, you did not.
And what's the
You didn't answer B2. Get back to B2.
What is the middle?
You like to just hurry, girl. Come on, slow down. Be more thorough.
7.
You'll be a phenomenal math student. Phenomenal.
Yeah.
7.
Suppose you
What's
find the
bigger
ratio
than
of
7?
side lengths of adjacent
Shortest
sides.
middle will be 4.
Two sides that meet
8.
right? So adjacent means
9.
they come together, right? All right.
9. What's
So-
bigger than 9?
The ratio is equivalent to the ratio of the corresponding side lengths in another. So that means this. Let's say,
10.5.
and let's say
You realize all this adds up to 19, right?
Yeah.
On the side.
that is similar to that. That is similar to that. That's what it's telling us, right?
Why is that useful?
So it says
No, I'm just saying.
this ratio is equivalent to the
No, why is
ratio
that
of the
useful?
corresponding
Tell me why
side lengths
that's
in another. Are the figures similar? So these are equal.
After 10.5, it's
Yeah.
12, 12,
Right?
13,
Because that angle's going to be the
17,
same. That angle, so if this is 12, this could be, let's say, 8, or even easier, 4. Right? And if this was 6, what would that be? 3.
17.5. You gotta reach. You can't just put it over there. You gotta reach.
Get it sooner or later.
Hello.
Maybe.
Yeet.
So that's what C's asking you. So guys, C, Schmidt, don't play around with it.
Well,
C's asking you guys that if you have adjacent sides and these are corresponding, are the figures similar?
yeet.
Well, if you're talking about, if I was to connect those, they would have to be. Okay, go ahead, put away.
10.5 is that middle number. So 4 is 10.5.
Pick that up. It doesn't like to follow me up. I think I might need to upgrade.
It follows me.
Oh no, it follows me, just not up. Uh-oh. What's up? No, we'll do it this way. All right, guys. Hoping I can blow this up here. Make it a little bit bigger. Nope. All right, so yeah, you're not gonna be able to. So I might have to just talk you through this one here. I don't know what's going on here.
Yeah, the internet's.
So just remember, guys, hey, if I can get the exit ticket up, I can get it up. If not, I'll just have you write down past. So, thank you. Test on Thursday. I will have, no internet right now. I will have on tonight, I'll put up the Kahoot. Okay, so you will need the mobile app for that. Jayla?
Does it need Wi-Fi?
No, it doesn't need Wi-Fi. I mean, you need internet connection to do an app.
What if you don't have an internet?
Wait, so do we like pass or internet down? My parents, what?
Okay, so here we go. Exit ticket. Homework is a unit review sheet that is due tomorrow. Exit ticket. Find all similar figures. Now, these are triangles. With triangles, if you're given some of the angles, how would you find if they're similar?
Or see if all the angles add up.
If all the angles are equal, if all of them are the same, that means the triangles are similar. So here I have 125 and 136. I would add those together. And what you want to do, which we don't have, you could just write down triangle A, 25, 136. Just write tri A. That would equal, that's 11, 6, 1. So that's 161. 180 minus 161 is 19. That means that right there is 19 degrees. So automatically, if I look at B, it has 25 and 19. What does that mean that one is? 136. So on my paper, I'd have triangle B. I'd write tri A is similar to tri B. And the reason why? All the angles are equal. It's just oriented differently. I could take that, rotate it, and it is a similar triangle, just much smaller. So that means they have corresponding sides, and that also means there's a scale factor. We don't know what it is, but there is a scale factor. That's only one. So if I come down here, I have 3. Here I have 30 and 94, which is going to give me 124. And I would go 180 minus 124. And I'm going to get 56. And so if that's 56, triangle C and triangle D are what? Similar. So I can look over here, 120 and 44, those angles don't even match up. So what does that mean triangle E is? Is an imposter. Make sure you do the unit review, and have a good night.